Good morning, good afternoon, good evening, everyone who's watching and listening. Thank you all so much for this opportunity. I would like
Excuse
to
me, sorry to disturb you, Tsunami. There's a feedback, Marcel, that I'm hearing. I don't know if anyone else is hearing it.
I'm hearing it, but I'm not sure where it's coming from. Is anybody online? Can mute their mic?
Try muting the mic on the computer for now that you are using in C2 and see if that helps.
All right, go ahead and see if the feedback is going on.
thank you. Can you hear me clearly now?
Yes, much better.
Thank you. All right. Thank you so much for this opportunity. Thank you so much, Dr. Volumore, Winklet, and Dr. Debian. Thank you, Phil. Thank you, everyone watching and listening. I'm Anko Senamiru Afunola, a graduate teaching assistant in the Department of Chemistry, Lagos State University, Lagos State, Nigeria. And I've been given this opportunity to speak on my topic, on my research topic, impact assessment of Badagry Creek on groundwater quality in Ojo community, Ojo, Lagos State. And I am being supervised by Dr. Badagry AO, who is here listening as well. So a background story, while growing up, I was always affected by water, that is drinking water. While growing up at home, we always had purifying substances put in our water to, purify the water and it wouldn't affect our health, so to speak. But then when I would leave my house and go somewhere else, maybe to visit, and I would drink their water, it always affected me. And so I had this consciousness about the quality of water and why I shouldn't just drink water anywhere because of how it can affect humans negatively, definitely. And so I can say this said building up that consciousness towards, or let me say an unconscious building up towards studying this research. And also when I was doing my internship, when I was in undergrad school, I did my internship at the Lagos State Environmental Protection Agency here in Lagos State. And I was placed in the potable water lab where we always tested for the water quality. And so that also, I can say, geared me towards understanding water quality and why we really have to take care of our water. And it also gave me, or it also built this interest in environment and restoring the environment in me. And so I can say all of these things, all of these reasons were building up and geared me towards studying this research. And so here are my outline. Moving on. Okay, so what do you think when you see this glass of water? It is just a plain glass of water, but it should make you think of something. Well, to me, it makes me think that, or it makes me realize that this is the ultimate aim for this research. Clean, safe water for all, for everyone in every community, everywhere. Clean, safe water, because water is essential to life and to everything that we do. Now my introduction. Groundwater is literally water present beneath the Earth's surface, and it accounts for about 30% of the world's fresh water. The remaining 70% is in our oceans, seas, which is otherwise undrinkable because it's salty, and the rest are also stored in ice caps, which is quite difficult to extract and purify. And we prefer groundwater over surface water for various reasons. Because of its convenient availability of its source close to where the water is required, because we can literally drill, or let's say extract or abstract water via wells wherever we are, because it is literally underground us. We don't have to go far away looking for a source of water or a stream or an ocean, especially for us who stay in urban areas and we don't stay in coastal areas. So also another factor is its excellent natural quality. which is adequate for drinking and for other purposes, with little or no treatment. We don't really need to treat groundwater so much because there are some form of filters. There are some things, or there are some rocks underneath the Earth's surface that serve as filter. Some cracks and some subsurface rocks underground that serve as a filter for our groundwater. So we don't really need to purify our water before we drink, unlike surface water, which is salty and needs to go through a lot of expensive purification processes and treatment processes because of its high level of pollution. And water from aquifers can be extracted through wells by drilling wells into the ground. And that's how we can extract groundwater for our use, whether for domestic, for industrial, or for agricultural purposes. Next. However, even though we prefer groundwater to surface water because of all these reasons, and even though it is less vulnerable to pollution compared to surface water, it is also still susceptible to some form of contamination, such as contamination from toxic compounds like petroleum, which could be spilled into the ground, maybe while being drilled or being exploited. It could be or vandalized. It could spill and then get into our groundwater aquifers, or when we apply chemicals and fertilizers in our farmlands, and then they seep into the ground or they seep into our oceans, which more often seep back into the groundwater aquifers. And also from microbial contamination beneath the ground. We have all of these forms of contamination that will get into our groundwater, and we need to treat them. That's why we need to always maintain water quality treatments to ensure that we have good quality water for everyone to drink. And also, groundwater can be susceptible to saltwater intrusion, especially for people. Many people in coastal areas face this. So what is saltwater intrusion? Saltwater intrusion is the movement of saline water, that is water from our seas and oceans, into our groundwater aquifers, which is dangerous because we're supposed to have fresh water, but now we are having salt water, which when it is in excess, it affects human health. And it breeds all form of other contamination like microbial contamination because it is salt water compared to when it is fresh. So how can saltwater intrusion occur? It can occur via excess withdrawal of water, excess pumping of water through our wells, which causes the earth to let loose, so to speak. And then the seawater can seep into our groundwater aquifers. Also, rise in sea level change, rise in sea level. If the sort of like an area having a tsunami or experiencing tsunamis, definitely there is a rise in the sea level, which would later on seep into the groundwater aquifers and contaminating it with salt water and other form of pollution which has been dwelling or being in the saltwater body. And the impacts of saltwater intrusion on groundwater are loss of freshwater vegetation. So instead of us having our freshwater vegetation, we begin to have our vegetation die because they are now being affected by excess salt and excess nutrients, which is not part of their natural composition. And we can also have another impact is the degradation of our water quality. Now, instead of us having fresh water to drink, we're having salt water, which is not necessarily, it isn't really nice for us. I can't really think of anyone who would like to drink salt water every single day, especially when it's excess, except if it's for medicinal purposes. And also the more dangerous aspect is the chronic diseases that this breeds in humans and also in animals because of saltwater intrusion. This is a diagram to show the sources of groundwater pollution, definitely from the sea. So from this diagram, you can see surface runoff from the farmlands, that is the over-application of pesticides or chemicals on the farmlands now being run off into the surface water, and which later on seeps into the groundwater. We can also see septic tanks. That is a very major source of groundwater pollution is sewage, domestic and industrial sewage, which is left untreated. And also, if you can look at the upper left, we can see wastewater treatment. But the truth is, many companies or many industries do not treat their wastewater well before it is let into the surface water, which ultimately affects fish and humans and plants and everything that is living in the water, and definitely still gets back into our groundwater through saltwater intrusion. And we can also see oil spills from the ships, and also some pipelines, some oil pipelines are close to the water and surface water bodies. And so when they get exploited or vandalized, this oil gets spilled into the water and then seeps back into the groundwater, which contaminates it. This is a diagram to show or just to illustrate saltwater intrusion. So as we can see from here, the ocean water is seeping in, or there's a rise in the sea level, and then it's seeping in gradually into the freshwater aquifer, and then it is abstracted through the well. So instead of us abstracting fresh water, now we're abstracting salt water, which is dangerous for domestic purposes, for agricultural purposes, and some other purposes that are critical for us. So the aim of this study is to evaluate the impact of the Badagry Creek on groundwater quality in Ojo community, Ojo, Lagos State, which is where I am currently based. And the objectives of this study are analysis of physicochemical parameters in water samples, analysis of trace metals in water samples, and data analysis using statistical tools, including descriptive analysis, Pearson correlation coefficient, cluster analysis, and principal component analysis. Yes, this is my methodology. So I carried out a sampling survey of the area first, of the local government area, to know the activities that are going on there and how I can take my samples, and just for ease when I go for sampling, basically. And then I went on for sample collection later on. And after sample location and collection, I went on to sample preservation right from the site and then to the laboratory. Then chemical analysis, and finally statistical analysis. Yes, the study area. Ojo is a local government and town in the Badagry division of Lagos State, Nigeria. And it is primarily residential, right? And it bounds the south of the Badagry Creek, which through Victoria Island, which is actually a very far distance, it bounds it, through the Victoria Island, it empties into the Atlantic Ocean. That is how large the Badagry Creek is. And the area, that is the Ojo community, houses some major markets such as the Yanoba markets, where food stuff and fruits and all of these things are sold, and the Alaba International Market. It is a very well-known market. It is well known mostly for its electronics, its sales of electronics. And I can also say that definitely that could also be a source of pollution, but we'll see why I said that as we go on. Also, the local government area consists of mangroves, swamps, and some sandy beaches. And the major sources of water supply in the area are hand-dug wells. They are shallow wells actually, but hand-dug wells. Some are residential, some are community wells, and very few of them are boreholes because the area is still a bit rural. Yes, and the major preoccupations or occupations in the area are fishing, trading, and sediment dredging. Like I said, it's still quite a rural area. Ojo is also home to the State University, Lagos State University, which is one of the most prestigious universities in Nigeria, which is the university I am currently studying in for my master's degree program, and where I am currently a staff as well as a graduate teaching assistant. Yes, these are my GPS for my sample locations. Yes, OWS represented here are Ojo water samples. That is those that were collected from the Ojo community closer to the Badagry Creek, and LWS is Lasso water sample collected right within the Lagos State University campus. So 5 of them were collected in the Lagos State University, while the other 10 were collected outside university. Yes, this is a map to represent the sampling locations using the GPS locations. The GPS, yes. Okay, sorry, let me go back to that. As you can see from the map, you can see the water body, and you can see the Ojo water samples that are close to the water body, and then the Lasso water samples on the other side, because this road that separates them is the Badagry Expressway, is the major road, and so the Lagos State University is on the other side of the road, while the Ojo community or the other Ojo community is on the other side. Yes, sample collection. So the groundwater samples were collected from 15 locations, that is from underground wells, all underground wells, no boreholes, in the Ojo community. Ojo community, Lasso included. And the sample locations were recorded using a GPS, a global positioning system, as shown in table 1 above. And the plastic bottles that were used to collect them were 1.5 liters and 0.75 liters. They were acid washed and used for physicochemical and metal analysis, or metal samples respectively. Also, the water samples that were taken for meta analysis, that is the 0.75 liters, were spiked with about 1.5 mil of concentrated HNO3 to the 1.5 liters were used to collect samples for physicochemical analysis. And those bottles were filled to the brim to also prevent, without bubbles, yes, to also prevent microbial growth. And from the site, yes, the samples were then taken to the laboratory and stored in the refrigerator at 4 degrees Celsius. Yes, the chemical analysis was carried out thus. pH and temperature of the groundwater samples were determined in situ with a pH meter, while EC, electrical conductivity, and TDS, total dissolved solids, was carried out at the laboratory with a conductivity meter. And acidity, alkalinity, total hardness, and chloride were determined titrametrically. Titrations, yes. And phosphate was determined using the colorimetric method. Nitrate was done with the ultraviolet spectrophotometric screening method, and sulfate was determined by turbidimetry. And they were all their concentrations were determined using a UV visible spectrophotometer. While the analysis for trace metals was done by acid digestion of the samples, and then the concentrations were determined with a flame atomic absorption spectrophotometer. Yes, these were some quality assurance steps I engaged in while carrying out the study. All the chemicals and reagents were of analog grade. They were standard, very pure, and all the solutions that were used in titrations were standardized. All the equipment used were calibrated. The conductivity meter, the analytical balance, the pH meter, they were all calibrated before use. And there was also replication of analysis to check and then the blank analysis was also carried out. Moving on. So here's my results and discussion. This table 2 is a descriptive analysis for the physicochemical parameters. In this, many of them, I compared them on their mean concentrations, that is for the chemical parameters, with the WHO limits. So in this, I used the excidence to check, to confirm, to see if the mean concentrations are really way above the WHO limits. And in this, all of them, or let me say most of them, were within the WHO limits, while nitrate was high above the WHO limit, giving an incidence value of 2.92. And I also have my Nigerian standard, that is the Nigerian standard for drinking water quality, to also compare with the WHO limits, to, yes, just to compare with the WHO limits, to ensure that we in Nigeria, we are in compliance with the WHO limits. And so, yes, and excess nitrates, from what we discovered, excess nitrates causes blue baby syndrome in infants, which is very dangerous, which is an obstruction or a difficulty in blood oxygen exchange. And this is an image showing an infant with blue baby syndrome. As you can see on the face of the baby, or yes, even all through the baby's body, you can see blue spots or blue pigments on the baby's face and on the baby's body. And this is very dangerous because it deals with the blood, and everyone knows that blood is life in humans and even in animals. And so these are the effects of nitrates in the system. Yes, this is the Pearson correlation for physicochemical parameters. In this, we're able to see strong interelemental correlations and associations between some of the parameters. For example, alkalinity and pH showed strong interelemental correlations at 0.794, and nitrates and EC, electrical conductivity, also showed strong interelemental associations, as well as sulfates and EC. So these are just some of this showed us that these locations, or these sampling locations, have similarities in this with these chemical parameters. That is, these chemical parameters were there's something that links them. There is a link between in these locations because of the physicochemical parameters. And so this Pearson correlation was able to show us the strong interelemental correlations. Principal component analysis for the physicochemical parameters. The principal component analysis groups the data into dimensions. It reduces the data into dimensions, and so helps to know the dominant parameters in each group. In this principal component analysis, we were able to generate 3 principal components, or the SPSS, that is the statistical package for social sciences, was able to generate 3 principal components. And in the first principal component, EC and total hardness, TDS, chloride, nitrates, sulfate, and salinity were dominant parameters, while in the principal component 2, pH and alkalinity were the dominant parameters. That also shows us a linking between these two and between all of these parameters in the locations or in the samples. While in the in PC3, temperature and phosphates were the dominant parameters. Yes, this is a dendrogram, that is the cluster analysis for the physicochemical parameters. And in this, we were able to generate 3 clusters. If you're cutting at the 2.6 index of dissimilarities, which is the standard for cutting the dendrogram, for us to know, for us to know how relevant this is. So at the 2.6 index of dissimilarities, we have 3 clusters. In the first cluster, we have phosphate, salinity, pH, temperature, nitrate, acidity, alkalinity, total hardness, chlorides, and sulfates being grouped together in one cluster. This tells us that there are similarities in this, or they are probably coming from the same source in these locations. And the second cluster only comprised of EC, while the third cluster comprised of TDS only. Yes, this is also a cluster analysis, but it is location based. So we used this was used to check the former one, the table and the figure 7. So in this figure, it is grouped according to locations. And if we're able to check through from the map and checking this, we can see similarities in the geographical distance, which is one of the principles for grouping in this cluster analysis, or we can use the quality parameters in these various parameters. So according to this, in cluster 1, we have 15, 14, 12, and 5, which are 50 years. In the cluster 1, that is cutting at the 2.6 index of the similarities. We have 1, 6, 13, 11, 15, 14, 12, and 5. Those are the locations that are grouped in the first cluster. And these are similar due to the high values or high concentrations in their EC and similarities in their EC, phosphate, and alkalinity. So this is why the dendrogram was able to cluster them up together. And then in the second cluster, which is locations 9 and locations 4, we have similarities in their EC, nitrate, and phosphate. But in the third cluster, which is 3, 10, 7, and 2, yes, those are the locations clustered there. We have sulfate, EC, and TDS being their similar physicochemical parameters. And then in the last one, we have location 8. Yes, we have location 8, which is segregated because it has higher values of TDS, chlorides, and sulfate. Yes. Now, these are my descriptive analysis for metals. I worked on, 8 metals were worked on in this study, which are zinc, iron, copper, lead, magnesium, calcium, sodium, and potassium. And from this descriptive analysis, the excidence values were higher for iron, lead, and magnesium. And the iron is probably due to the clayey nature in Lagos State. Lagos State is the soil in Lagos State is very rich in iron. And definitely iron is abundant everywhere in the world, that is in the soils in the world. But particularly in Lagos State, it has been discovered that iron in our soils are abundant. And so this is, yes, so this can account for the high values of iron. And then for lead, we have 30.0 as the excidence value, which is very high. And then for magnesium as well, 7.36. And an effect of lead in humans is plumbism, and it affects infants generally. It affects infants mostly because it affects their brain, it affects their intelligence quotient, it affects their kidneys and their skeletons, and we can see this in this diagram. In this picture or this image. It affects their brain, irreversible brain damage, headaches, irritability, learning problems, muscular weakness, even the kidney, pain in the abdomen, constipation regularly. And so these are the effects of excess lead in humans, especially in infants. This is the Pearson correlation for the metal analysis. In this, it was evidence that iron correlated with lead, magnesium, and calcium, revealing that they are probably coming from the same source. Possibly with for lead now, it is not a metal easily found on the ground, except from pipes. And in wells, we can't really have pipes unless if it was boreholes. And these samples were collected from hand-dug wells. And so this gives an influence of the Badagry Creek into the groundwater aquifers. And so magnesium also correlated with calcium, which is normal for total hardness, and lead as well correlated, shows strong interelemental correlation with calcium and magnesium. The principal component analysis for the metals. We had two principal components were generated for this study for the metal analysis, and zinc, iron, lead, magnesium, and calcium showing up again as the dominant parameters in PC1, and in PC2, sodium and potassium were the dominant parameters. So this tells us that there is this grouping is also giving us an indication of the influence from the salt water, that is from the Badagry Creek into our groundwaters, especially for those locations that were closer to the Badagry Creek. Yes, this is the dendrogram showing clusters in the metal analysis. And here we got, yes, in this we had cutting at the 2.6 index of dissimilarities again. We have 1, 2, 3, 4 clusters. And in cluster 1, we have 5, 2, 1, 4, 3, which correlates to magnesium, iron, zinc, lead, and copper. And these were segregated because of dissimilarities in their concentrations. For instance, in the concentrations from the descriptive analysis, you will be able to discover that copper to magnesium were similar. That is a range of 0.01 to 3.68. But when we go down to sodium, calcium, and potassium, we had higher values of 42, we had higher values of 18 and 30. So that is why they were distributed and segregated away from or apart from the other metals in cluster 1. So cluster 1 gives us a cluster of magnesium, iron, zinc, lead, and copper, while cluster 2 comprises of sodium, cluster 3 comprises of potassium, and cluster 4 comprises of calcium only. This is also a location-based, a location-based dendrogram, still for the metal analysis. So in this, we have 6 clusters, cutting at the 2.6 index of dissimilarities. Cluster 1 gives an indication of 8, 7, locations 8, 7, 1, 10, and 9. Cluster 2, 6, 13, 15, and 14. Cluster 3, 3, 12, and 11. Cluster 4, location 2 alone. Cluster 5, location 4. Cluster 6, location 5. And it did this also based on the similarities in the metals. That is, these locations have similarities in their concentrations, or in their level of concentrations of the metals. For instance, cluster 2 had similarities in zinc, lead, and iron, while cluster 3 had similarities and high values of iron. That is why they are segregated from cluster 1. Cluster 4, that is, cluster 4, which is given only location 2, and cluster 5 given location 4, cluster 6 given location 5, were segregated because of their high concentration of calcium. And when we checked, this was verified using the raw data and also with the map. As was shown below, above. Yes, the high level of calcium was higher in these locations, and that is why they were distributed into clusters of their own. And then this also gives an evidence, of the saltwater intrusion from the Badagry Creek, because when this was verified using the map, it showed that those locations that were close to the Badagry Creek had more similarities in their high level, in the high levels of their metals compared to the locations that were far off away from the creek, such as those samples taken from the Lagos State University. Yes, and this is my contribution to knowledge. For the first time, this is the first work that is been done on the impact of the Badagry Creek on groundwater aquifers in Ojo community, Lagos State, Nigeria. So for the first time, there's good information about the impact, and it also gives information in line with Goal 6, SDGs Goal 6 and Goal 3, good health and well-being and clean water for all. And also it helps with data for planning by population agencies for sustainability and management in the economy. Yes, my conclusion from the study, or from everything that was, from all the data that was investigated, it shows that there is a direct or possible direct impact of the Badagry Creek on the sampling locations, especially those close to the surface water, that is the Badagry Creek, given by the high concentrations of some of the parameters, such as nitrate, iron, lead, and electrical conductivity. And also, as I said earlier, the study aligns with Goal 6 for Sustainable Development Goals, which aims at providing clean, safe water for all. And this tells that this gives an indication that there is need for monitoring, for protection, and for good, proper management of groundwater aquifers in Ojo community, Ojo, Lagos State, especially for those residential locations closest to the Badagry Creek, which when this salt water, or when these contaminants get into their water and they are not even aware of it, it affects them, and then they have diseases, or they suffer from diseases, and yes, they suffer from diseases that are ailing them, but they don't even know where it's coming from. They don't know the source, because they are not really aware of this concept. But if the federal government or governmental agencies that are involved in sustainable monitoring of our groundwater can be involved, they can ensure that these water samples or this groundwater are properly monitored and managed, especially those closest to the Badagry Creek. Yes, my recommendation is there are some dredging activities that are carried out daily at the shore of the Ojo ferry, that is at the shore of the Badagry Creek, close to us here at Ojo. And I can say that it affects the change in the sea level. So it could be a cause of the rise in the sea level, which could also be a factor for saltwater intrusion into groundwater aquifers in the Ojo community. So government officials should take note of that and devise monitoring and enforcement policies for those activities, because many of them are done indiscriminately. Thank you. And these are my references. These are my acknowledgements. I just want to thank everyone watching and listening. I thank my supervisor, Dr. Badagry, AO, an associate professor here in the Lagos State University, Department of Chemistry. I thank the whole Department of Chemistry, Lagos State University, for the opportunity and for the ease for carrying out this study. I want to say a big thank you to Pearl Bagan. I met her at the Commonwealth, at Commonwealth poster presentations. She's of Department of Chemistry, University of West Indies, Mona, Jamaica, here where I'm presenting. Dr. Gollymore, Winkler, Department of Chemistry, University of West Indies, Dr. Debbie Ann Gordon-Smith, and the old Department of Chemistry, University of West Indies. Thank you all so much for listening. God bless you.
Okay, thank you very much, Sanaka, for your presentation today. Really appreciate it. Now we have a couple of minutes for questions. Is there anyone who has a question?
Okay. Sanaka, thank you so much for your presentation. I just want to ask you, did we see any correlation between the nitrate levels and Blue Belly syndrome occurring in the community, or in learning retardation and the high levels of lead?
Sorry, ma'am, please can you repeat the question? I didn't get that.
Right, I'm saying, do we see any correlation between the nitrate levels and baby syndrome in the community? Do we see blue baby syndrome in the community? And do we see learning retardation from the high levels of lead? Can you make that correlation to say it's affecting the community?
Okay, thank you very much. So when I did the sampling survey and also while carrying out my sampling, I observed the children, yes, the infants and people in the environment. And I was struck by the level of, yes, I wouldn't say disease on a high level, but I would say I was struck by the sicknesses that I found, especially for those closest to the Badagry Creek. So yes, I haven't gone back yet to study about the blue baby syndrome that might be in the community, but I was able to notice the high level of sicknesses in those infants and even in the adults in those areas, especially those closest to the Badagry Creek.
All right. Thank you so much, Sina. We spoke about the wells being hand dug. Is it that all of them were the same depth? Because if you're using your hand, that may be a little bit challenging. Were they all the same depth?
No,
muted.
Sorry, they weren't all of the same depth.
About what depth was that?
Okay, so okay, yes, they weren't all of the same depth. Some of them were deeper than others, but I was able to take the water depth. I was able to take note of the water depth and the well depth of each well I sampled.
Okay. Could you repeat that response, please?
Okay, I said not all of them. They weren't all of the same depth.
Right.
Can you hear me? Yes, they weren't all of the same depth. So I had to take notes. I had to measure the water depth and the well depth of each well that I sampled.
Okay, you measured it. Measured each of them. A follow-up question to that. Did you look at potential correlations between the depth and the results of your physiochemical study?
Sorry, ma'am, please repeat that question.
Did you look at any possible correlations between the depth of the well and the results of your physiochemical study?
No,
Were there variations in, say, your metal in relation to the depth of the well?
Okay. No, I haven't done that yet.
Is there any last question that anyone has?
Yes, I have a question, Tsunami. Thank you for your presentation. I enjoyed it. It's my area of work, so I loved it, of course. Anybody in the chemistry department knows that. Could you go back to your map? I was driving, unfortunately, at the time when you were showing where your sites were located. So I wasn't able to see the map because I'm curious about the PCA analysis and what you saw in terms of where the sites were located compared to the results that you obtained.
Yes, ma'am.
Okay, thank you. All right, so where is the creek in relation to these sites? I'm not sure if I can see that. These are groundwater samples, right?
Yes, ma'am.
Great. And there is surface water flow nearby as well?
Yes, ma'am.
I'm curious, did you take any samples from the creek as well and to compare to your groundwater samples?
No, I didn't.
You didn't, okay. All right, that would be interesting to see. And I may have missed it, so I apologize if you said it and I missed it. What was the frequency of your sampling? Was this a one-off or was it over a number of sampling trips?
No, I went on 2 sampling trips.
2, okay. Were the rainfall patterns about the same? Was it wet season or dry season or both?
No. The same season.
Oh, it was in the same season. How far apart were the samples when the sampling occasions?
The sampling locations.
Sorry, no, occasion, sorry. When did you sample? How far apart were the times?
Oh, okay. About
I'm curious, I'm asking because I'm curious about any seasonal changes or changes that could occur with time.
And then it was about 6 months.
Oh, okay. All right. Right, so it's possible that there could be changes with the seasons,
Yes.
but we wouldn't be able to tell from this. I noticed when you did your cluster analysis that there were some things that were similar. For example, phosphate was similar in cluster 1, you said. EC alkalinity, cluster 2 nitrate and EC. Are those related to location as well? Maybe do you know what the source of the different nutrients and various parameters are? Or can you, I know you wouldn't have done necessarily any isotope analysis to identify, but do you see any correlations between where the different, like high nitrate, high phosphates is located compared to urban areas, farming areas, anything like that? Were you able to see those sorts of associations?
Sorry, ma'am, please repeat that.
Oh, I'm sorry. I'm asking if you saw any correlations or associations between the high levels of certain parameters. For example, you said nitrate for cluster 2, phosphate, alkalinity for cluster 1, sulfate in cluster 3, if I recall, and then site 8 was totally different. I'm just wondering if you saw any associations with the locations, meaning is there urban areas, farming areas, industry, anything at all that would be the source of these different nutrients and other parameters?
Okay, so the correlations that I was able to generate from this was that many of those locations that were close to the Badagry Creek, which is like it's a major source of transportation for boats, for boats, for ships, and all of those, because the area is still quite rural, so there are not any industries in the area, and mostly the occupations in the area are fishing, dredging of sand, and trading. Those are the major occupations in the area. They are not industries in the area. So the major correlation that we could get from this is that those locations that were close to the Badagry Creek, which is a major source of transportation and could be susceptible to oil spills and other forms of pollution, was highly or more contaminated or had higher levels of concentration compared to those that were farther from the creek.
Oh, so most of the activities occur right around the creek, which would make sense because that's a major source of water, I assume. But from all indications, you're saying that much of the water, the groundwater and the creek, is probably high in concentration of nitrates, etc., and possibly bacteria, because you said that you're seeing certain people, diseases throughout the population. That's really sad. So they're not treating the water before they use it?
No, it is drawn straight.
Because it's rural. I see. Interesting. Where was Site 8 located? You said, I think this was the one you said EC was it close to the coastline? Because you said you also suspect seawater intrusion. Did you by chance do any bromide analyses?
Any what?
Bromide.
No, I
In addition
didn't.
to chloride, no? Okay.
No, I didn't do bromide.
Yeah, that one is useful. If we look at chloride bromide ratios, we can, sort of determine whether or not, well, what sort of, where the source of the chloride, whether it's seawater or from elsewhere. And I noticed you said some areas had higher alkalinity as well, and EC, etc. Did you look at the geology in the area to see how it may compare to some of the results you got?
Yes, so that is a project that is also being worked on, the geology area.
Okay. All right, sounds very interesting. Thank you for this. We have a lot to talk about.
Thank you so much.
Okay, thank you so much, Tsunami. All that's we're a little bit over time. So all it needs for me to do is say thank you for agreeing to do this seminar for us this morning. And wish you all the best in your program. How close are you to finishing, do you think? The question that no one likes to answer.
Yes, by next month, I should be done with my master's program and then moving on to PhD.
Okay, awesome. Congratulations in advance. All right, so thank you very much, and everyone.